LeetCode problem 33, search in rotated array, sorted array, which has been rotated. This is a medium problem. Basically, we are given an array as we see here, but it's rotated. It's medium, but I think it's actually pretty difficult. So we are given an array which was rotated at some index. The original array was sorted, and now it's also sorted, but it's rotated. So half of the array is sorted, and then another half is sorted. And we need to find the target number in of log n time. This limitation of log n time means we need to do binary search. Otherwise, there is just no option. We would get to of log of n. Okay, so let's draw this target array and see how we could solve it. So we have the array of 4, 5, 6, 7, 0, 1, and 2, and we need to find the target, which is in this case 0. We know that we have here two increasing arrays. We don't know their indexes, okay, but in a minute we'll try to understand how do we know if we are in this part or on this part. But we know here that we have something increasing, and we know here that we have something increasing at some point in the array. Doesn't need to be in this index, but we know that the last part of the array is increasing, the first part is increasing, and at some point this drops and changes. Another thing that we know is that this last value is smaller. This is smaller than this value. Okay, so we have this like this, and this value at the end is smaller. So let's say I land at some number. Let's say I land at this number. Okay, how do I know if I landed on this left line? Okay, this would be the left side, or whether I landed on the right side, because this is important. With this, we could do the binary search. If the number I have is larger than the rightmost number, this means that for sure I'm here on the left side. If the number I landed on is smaller than the most left side number, then for sure I'm on the right side. Okay, so we have a new information. We know if we are on the right side or we are on the left side. If I'm on the right side and the number I have is higher, it could be here and it could be here. If it's smaller than this right side, then it's only here, and I can actually move the left pointer to here. The middle would be here and the right would be here, because I know that my number is larger than the current number that I landed on, and I know I'm on the right side, and I know, okay, so you see we have all these conditions. So if I know that I'm on the left side and I landed on this number, how do I know I'm on the left side? It's because my number is larger than the rightmost side, so I know I'm on this line. If the number is higher and I'm on the left side, then it's only here. Okay, if the number is smaller and I know that I'm on the left side, then the number could be here, but it also could be here. It would be here if the target number is higher than the leftmost side. It would be here if the target number is smaller than the rightmost side and smaller than our number. Okay, and with that information, let's begin coding this. And when we code this, we need to understand first if we are on the right side or on the left side, and then depending if we are on the right side or on the left side, we'll add additional logic in order to know whether to move the left, middle, and the right pointers. The left, we would move the left to the right or the right to the left. Having said this, the only thing we'll do is just check our state and decide if to move the left to here or the right to here. This is the only check that we are going to do. No more optimizations, no needed. Because you see, if we are here and we are moving the right pointer here, okay, just because we suspect the value is smaller, we could do an optimization and move also the left to here, but there is no reason and it's hard and we don't know where exactly to move it. So even though we have here many bigger numbers, if we know that we're on the right side and the number is smaller than ours, we'll just move the right pointer to the middle point here, and that's it, because it's enough to just remove move the right to the middle or left to the middle in order to have a binary search. And with that, let's start coding this. Okay, so okay. Okay, so I'm going to start by defining the left and right pointer. So int left pointer and right pointer. The left pointer, it's a binary search, is pointing to 0, and the right pointer is pointing to the right of the array. And now, in binary search, we continue the search as long as the left pointer is smaller or equal to the right. This is a very good tip to know. This is the AND condition. What is the middle of the binary search? Now, we have the left, we have the right, now we need the middle. The middle would be left plus right, divided by 2. Okay, and now because we want to know what is the current value that we are in the middle, and all these conditions are going to be very complex. In this case, I tend to put all the variable single letter variable, so everything is easier. So the current value is the nums at the middle point. This is the current value, and let also the target value be with a single letter. T is target. Okay, so we have V. V is the V is the middle value, T is the target value, and now we can already check if by any chance the current value is the target value, then just return its index, which is M, because V is pointed to the middle number. And now let's check if we are on the left side or on the right side. How do we know if we are on this left side? We know that we are on the left side if the number is bigger than the leftmost value, because all the numbers here are smaller than all the numbers here. So if the number, it's enough for the number, the current value that we landed on to be bigger than the leftmost value, for us to know that we are on the left line. So if the value is bigger than the top left value, then we know for sure that we are on the left line. And else, we know for sure that we are on the right line. Okay, so if we are on the left line and the target value is bigger than the current value, then we know for sure that we can just move the left to the middle value plus 1, because we had these 2 lines here, right? We had these 2 lines, and we know that the number is bigger than this, so it cannot be here. We landed somewhere here, so the target value must be here, somewhere on the right side of where we landed. This is the middle, this is the target, should be somewhere here. So we just move the left pointer to the middle plus 1. Else, if we are on the right side and the target is smaller than V. Now, if the target is smaller than V, it could be here, or it could be also on the right side. So if the target is smaller than V and the target is also smaller than the leftmost side, nums L, which is the leftmost side, then this means again that the target number is here, but we will just move this pointer to here. It's enough to move it to here with the expense of having also this. We don't care. We just know that number is on the right side of where we landed. So left pointer would be middle plus 1. Okay. Now, else if the target is smaller than v, however, the target is also larger or equal to the left side, then we know that the target is on the left side and we can move the right pointer to m-1. Okay, so with that we finished all the conditions for the value for the fact that we are on the left line. And now if we are on the right line, okay, the right line is fully smaller than the left line, then if the target value is larger than the current value and the target value is smaller than the rightmost value, then we know for sure that we can move the left to m plus 1, because we know that we are on the right side. Our target number is on the right side. It's bigger than value, but it's still smaller than the rightmost side, so it's on the right side. Else if the target value is greater than v and target value is larger than the rightmost side, then we know that the value is larger, and not only is it larger, it's also on the left side. Okay, so let's say not only it's larger, but it's also on the left side. So to move to the left, we move the pointer of the right to m-1. Why m-1 and not m? Because we know it's not equal to m, otherwise we would exit here. Okay, another condition is if t is just smaller than v and we know that it's not larger than right, then in this case we know that the value is on the left side, so we just move the pointer and to m-1. Here we can see that we can do a few optimizations here, because we have multiple conditions where we move to m-1, so we can move this condition to here, but I don't think there is a reason now to do this. Let's check that compiles, everything is okay. Of course, the latest value should be to just return -1 if we didn't find anything. They asked in the problem to return -1 if we didn't find. Okay, line 3, let's just do a minor fix on line 3. Yes, here. Here, it's a comma. Okay. Okay, and with a few minor compilation fixes, we have the solution. Let's try to submit it just. And now we'll do a final review of this. Let's close this. Submit. Okay, so it looks good. So to just do a quick recap of what we did, we knew that they wanted off log of n, so we knew we need some kind of a binary search. We know that the array is sorted, only twisted, so we knew that one part of the array is larger than the other part of the array. Okay, and next we only wanted to know if we are on the left side or on the right side of the array. If we are on the left side, then it's possible for the number to be on the left or on the right. No need for more optimization. Either it's on the left or on the right. Same for the right side, and that's it. In this way we found the output.